this form inside here. So we apply our integration to the right side of what we got in part I. So integrating x squared plus 3x squared ln 3x will arrive, we will get x cubed ln 3x plus c. Because integrating this, we get back our original function, right? Okay, then it is a matter of manipulating this one. So we separate it into two separate integrals. Okay, and then we bring this to the right side. So this part will be 3 integrate x squared ln 3x dx. Okay, then minus away your integration of x squared, and integration of x squared will be x cubed over 3. I'll just group all the constants together as plus d, and then final answer will just be dividing everything throughout by 3. So I need the very final step for yourself, yeah? Part 2 for question 7. Okay, for question 7, part 2, we want to integrate sine x times e cosine x plus 1 dx. Okay, in other words, we can expand it to say as sine x e cosine x followed by plus sine x. Okay, yeah.
The last one, why didn't you take the constant 3 and divide it across?
Last one, right?
For me on the constant,
The 3.
it just disappears.
Yeah, say do it yourself. Yeah. Do it yourself. Okay. Yes, actually. Okay. Actually, right. Sorry, I suddenly thought my other students. Yeah. Later parts you got it wrong. I think then you need to check your.
But like, it's not the working one, it's the constant.
Constant wrong. Okay, later I come to it. Okay, so question 7, part 2. What was I saying? Okay, so we want to integrate this, we expand it and we observe this. Okay, but from our answer in 7 part I, right, we actually have negative sine x e cosine x. So what we can do, okay, is to just apply what we know first. Okay, which is that negative sine x e cosine x, when we integrate it, we should be getting e cosine x plus c. Okay, I can take this negative 1 out. Okay, which means that the positive integration of sine x e cosine x will be equals to negative e cosine x minus c. Okay, so back to our original expanded form here. This would mean that it is two separate integrals. Okay, of sine x e cosine x, and then also the other one is sine x. So the one on the left side, we already now know that it is negative e cosine x but minus c. And then for the integration of sine x, we know that it is negative cosine x. Okay, for convenience, I'll just drop the minus c and place everything as a plus c. Okay, so this will simplify into negative e cosine x minus cosine x plus d. Okay. your partial fraction, you're able to get this. So really, are you able to get this partial fraction? Okay. So with this partial fraction, then let's tackle the integration directly. Okay. So in order to integrate x squared over 2x plus 1, x plus 3 squared, we are looking at integrating the partial fractions. Okay, so it is individual fractions. We recognize that 1 over 25 is a constant, so we are actually integrating 1 over 2x plus 1, which actually gives us a ln. So I bring out the 1 over 25, ln 2x plus 1, not forgetting to divide by the coefficient of 2. So let me just adjust the number, 1 over 25. Okay, so that is the very first partial fraction. Then in the second one, likewise, in the denominator it is x plus 3 and it is to the power of 1. So we have 12 over 25 as a constant, which we can do the same thing of bringing out the 12 over 25 and then ln x plus 3 divided by 1. Okay, so that is for the first two fractions. For the last fraction, because the denominator has a power of 2, okay, so it is not going to integrate into ln. Okay, we need to observe that this is the same as negative 9 over 5 x plus 3 to the power of negative 2. So we apply our power rule and we get negative 9 over 5 x plus 3 power plus 1, so we get negative 1, divided by negative 1, multiplying by coefficient of x. Okay, then we proceed with simplifying. Sorry, forgot plus c. Okay, and that will be answer. Then final one, question 10. Okay, so in question 10 part I, we are given the first derivative, which is 2e to the power negative x minus 3e to the power of 3x plus 1. We want to find the exact coordinates of the stationary point of the curve. Okay, so that means that for us to find the stationary point, your f prime x must be equals to 0. So we attempt to actually solve this question. Okay, so in your attempt, we can change the e to the power negative x into a denominator e to the power x. And then in this case, e to the power 3x plus 1, we can see it as e to the power 3x times e to the power of 1. Okay, but even at this stage, you may find it difficult to actually go about solving it. Okay, even if you multiply across by e to the power of x, even if getting this part here, you may find it a challenge as well. Okay, so what you could do, actually, is it challenging to solve this question again? Can solve this one? Can? Okay, so, sorry, I was looking at my own answers, I did it by substitution, but actually it's okay. So, we proceed with solving. So, e power of 4x, never mind, sorry, let me backtrack a bit now. Plus 1, 3x plus 1, e of x, 4x plus 1. Okay, then we will arrive at e to the power of 4x plus 1 equals to 2/3, and we can apply ln on both sides. Okay, and that will arrive at 4x plus 1 on the right hand side. Since you can break down the power, followed by ln e, and ln e is equals to 1. So 4x equals to ln 2/3 minus 1. Be careful, there's no brackets at all, it's just ln 2/3. And then x equals to 1/4 ln 2/3 minus 1/4, where I divide across by 4. Okay? Either you leave it in expanded form or you leave it in factorized form. Either way is fine. But that is just the x coordinate. Okay, the question wanted x coordinate, so that will be the x coordinate. Then in part 2, we want to find the equation of the original function. So we got to integrate. So integrating the given derivative, 2e or negative x minus 3e over 3x plus 1. Okay, what we will eventually get is keep the same thing, not forgetting to divide by the coefficient of x, followed by the other one also the same, and then not forgetting to plus it. Okay, and fx simplifies to negative 2e of negative x minus so on, right? And then the question actually provided information that the curve intersects the y-axis at y equals to 3. So that means that in the coordinates of y equals to 3, since it cuts through the y-axis, your x is equals to 0. So therefore, when fx equals to 3, okay, we solve and we get 3 equals to minus 2 minus e plus c. Okay, and c is equals to 3 plus 2 plus e, which is 5 plus e. And therefore, our fx will be this function.